Hello and welcome to our Connected World podcast brought to you by TE Connectivity. I'm your host, Michelle Dawn Mooney, and today we're talking about software defined vehicles allowing for upgrades with ease. We have a great guest to bring on for this conversation today. Rudi Ostermann is the Vice President and Chief Technology Officer for TE Connectivity's Global Automotive. Rudi, thank you so much for being with us today.
Thank you, Michelle. It's my pleasure.
Looking forward to the conversation. Before we dive in, can I ask for you to give us a brief bio if you can before we get started?
Oh, yes. I spent basically my entire career in the automotive and in the connected automotive business with several companies, including Sumitomo and also Lear Corporation. And for the last 9 years, I'm in TE Connectivity, who was always my biggest competitor. So towards the end of my career, I wanted to spend time there to really understand why that is. And I found out it's really true. I have been some time in Asia Pacific. Now I'm back in Germany, and as the CTO for the automotive business, there's a lot of things which are changing right now in the world, and this is what we want to discuss today.
And I love the fact when you talk about the competitive edge here, and then here we are. So really looking forward to this conversation. So let's start here. In your recent TE.com article, you are discussing a shift in consumer behavior, notably that instead of horsepower and acceleration, today's car buyers are more concerned about comfort, connectivity, and of course, as always, safety. So what does this mean for the design of technological architectures developed over the next, say, 5 years?
Yes. So what we have seen is something which only happened recently, and especially in China. And kind of like a sign of that was at the Shanghai Motor Show. I think it was in March. You could see that the customers are going to the Chinese OEMs rather than the multinational and the traditional OEMs. And part of the reason is that they are offering in their cars things which are interesting for them, right? And in my generation, I was growing up with this horsepower thing, the biggest displacement, acceleration, and all of that stuff. But today, it's about the convenience, the connectivity, of course, also the safety. And this is already something which is more software defined, right? So, and that means if a car is in software defined, you need, first of all, more electronics. To handle all this electronics in the car, then it has a change also to the physical layer, which is the business we are in. And that means something which sounds at the first sight far away, like software, we are not a software company, has an impact, of course, to our business, because it will change the way how a car is designed and how a car is put together.
So what's different today than from 3 to 5 years ago in designing a software-defined vehicle, or SDVs, as we will call them in this conversation? How are these differences shaping the design of the vehicle architecture and then influencing the types of components that are now required for these architectures?
Sure. And there, of course, we are in a transition, right? We have still the legacy OEMs, and we have some which are kind of like, let me call them challengers, right? The ones who are really doing it in a very software defined way. And we have all these gray areas in between. But to talk about how the challengers are approaching it is they are looking from the system point of view. They are looking from the software point of view to this entire thing. So it's not anymore that you have subsystems like a airbag subsystem, like whatever, heated seat, any other body function, the engine control, the braking systems. In traditional cars, these are all subsystems which then somehow are getting together to a whole system in a traditional vehicle. The new approach is from the beginning, you have a systemic approach. So the software is in the middle, and then you have in the end all the, they serve the system, they bring it together so that it is a centrally approached design and not so much diversified in terms of systems as we have today sometimes.
I want to dive a little deeper with that. You started talking about the differences between the SDV and a traditional automobile. So, what are some of the key differences that come to mind when it comes to the differences between the two?
So if we start, for example, with companies who have adopted the autonomous driving early on, right? If you want to do autonomous driving, you need to have a computer who is doing that for you, right? You have, of course, the software, and then there's a computer who is doing it for you. It means you have a higher content of electronics for that purpose. And if you have that, you can then start to add other things to it, which are for the traditional OEMs done in a different way. And the fuse box is a good example. In a traditional OEM, you have a fuse box which is hardwired. You have it with those melting fuses. You have it with the electromechanical relays and so forth. When you have already electronic, you can do that also electronically. And while you are doing it, you are getting more benefit out of it, because if, for example, a circuit is protected by an electronic fuse instead of a melting fuse, it means you can also monitor the state of health of that circuit, and you can switch it off and on depending on the requirement, and you can even change that over lifetime. So the electronification of the architecture gives you a lot of advantages, and also managing the entire car and managing, for example, the circuit sizes you have.
You talked about kind of an ever-changing period that we're in right now, because things are just happening so rapidly with the technology. So, what is making this shift possible now?
I think what is making this possible now is for sure the user request for it, and this will give really a boost. If you think about ADAS, it's not new, and we were 5 years ago we were a lot talking about it, and we thought, yeah, that is the next big thing, but we were getting to a limit, to a technical limit. But the difference now is that people want it more, right? It's this software-defined vehicles with all the convenience what you have. You get connected to the infrastructure. You have on the passenger seat, you can watch movies. In the rear, the kiddies, they can play games. And while you are driving to work, you can have you can be already on a conference call because you are connected already, and everything is so convenient. This has been now seen as something which is very interesting for the consumers, so they are buying that cars, and consequently, everybody is now looking at software-defined vehicles, because it seems that is then going to be the move in society. And if I may add, it's not really decided now if this will happen in all places. We see it very strongly in China, and we know that those Chinese brands are also coming to Europe and the Americas, but we need to wait and see how the consumers there will decide, right? Are they going to adopt that? Do they have the same thinking? Do we have a difference there? So it's something which is evolving, and that's why it's so interesting for us, because we have a lot of change points and opportunities.
You talk about so many amazing factors to the topic at hand. Being on a conference call, having that technology for the kids, a lot of good things happening here. But let's talk about some challenges, especially, excuse me, 3, 2, 1. Let's talk about some of those challenges. What are the design challenges for making SDVs engineered for reliability, efficiency, safety, and then really a buzzword right now, sustainability?
Oh, yes. What's happening then, basically together with the software-defined vehicles, is also kind of like, as a setting, they are always EVs. So you could think about having an ICE engine, of course, a combustion engine, with software-defined vehicles. That's technically possible, but somehow it doesn't fit, right? Because that's the old way. The new way is it's an EV, it's software-defined. And then what comes together with it is the vertical integration of how a car is put together. and this is more segmented. You have seen maybe on YouTube or elsewhere those pictures how a car is in a different way now put together than traditionally, and then in itself means you have a different architecture. They call it also zonal architecture. And with that zonal architecture, you are getting different requirements for us, right? If the harnesses are getting smaller, it means they can also more likely be produced automatically. And by the way, they are also going to be put into the cars in a greater part automatically. Traditionally, it's a big piece, and it's a big hassle for the traditional OEMs to put that into a car and make all the connections. It's a big chunk of work. So if this can be automized, then it means for us the components on the wiring harnesses which we produce, they have to have different requirements, right? They need to be ready to be automatically put into the vehicle, but also that the harness is automatically produced in a more efficient way than we do today. This goes together, by the way, with miniaturization, which is good for sustainability. The less material we have, the more sustainable it is, beside of having the material itself sustainable.
You talked about earlier how consumers are really driving this for us, getting this done now, and no pun intended with driving there. But in what ways can we expect consumer demand for comfort, connectivity, safety to really change the process for designing and then producing cars, especially around the automotive platform itself?
Hmm. I thought it's not a direct link, right? This is, the cars, the consumers will kind of like demand the cars, and the cars will change the architecture. And with the change of the architecture, we are affected with our business. And of course, if I reverse it, our ability to adapt to this new architecture, our ability to understand what's going on in the market, of course, then makes us ready for having the right components for our customers and in the end for the consumers to make that entire thing happen.
How do you foresee this shift towards what we talked about, comfort, connectivity, safety, shaping the design of electric vehicles?
Yeah, this is what I was trying to mention also earlier. It will change the architecture, and architecture means I talked already about all these subsystems, which are kind of like independent to each other before, right? In the traditionally designed vehicle, and if this is now centrally designed with putting the software in the middle, and also the so-called zonal architecture, it gets a new picture. It is a different way of how you put the things together. So this is how it changes. It's the indirect approach to it. I mean, the indirect customer requirement, which is changing the architecture.
You noted in your article that historically vehicle customization focused on physical parts, but now that is all changing. Software is enabling much more variation, as we've talked about briefly. So, what are the engineering challenges in enabling this variation?
Yes, you see, if it's more software, it means also everything you want to do with software, similar to your iPhone. Everything you want to do with software needs already be available in the physical layer, right? And that's basically to start with, it's good news for us, right? Because we are making the components for the physical layer, and it means if the physical layer is complete, if it's kind of like always high version, it means we can sell more components. So basically, that's good news. On the other hand, as I said, if the architecture is changing and the requirements are changing, also it gets more commoditized. So it's not anymore so much customized for each of the OEMs, the solutions. It will get more, kind of like, as everything is getting more systemic. And so also the connectivity is getting more systemic. And we see it already in data connectivity very strongly, where those connections to the cameras and connections to these high-performing computers for the data exchange, they are pretty much standardized already. So that is going to be a challenge. right? So to define the standards, to be first in the standards, right? To design the standards. So that is going to change in our business.
And it really is changing so much from a car buyer perspective when you think of, well, which package do you want? Because once you miss the boat, if you don't buy it right off at the top, then you're going to miss out. So, how do you see SDV customization evolving over the next decade?
Yeah, well, we will see. This is really the end users, the consumers who are going to decide that. To your former point, you're absolutely right. If you have a mobile phone or your smartphone, and there are few things you decide on the physical layer when you are buying it, right? And one of the things is the memory, right? And if you opt for a small memory, and then maybe if it's not enough, you suffer later on. And this is going to be maybe the same thing with the physical layer in the cars. If you are not buying the high version, then you will have some limitations. Of course, it will be a little bit different. Let me point out again one thing is there is not one software-defined vehicles. The companies will compete in what it is, right? And you will have the approach of companies who are saying, okay, I'm more on the low cost area of it, right? I'm not going to do all these fancy things. I have a certain budget, right? And I have a certain customer in mind who's buying that. So there are these things, which is maybe then even more commoditized. And then there will be for sure those luxury car makers and the high-end car makers on the other hand, who will drive it really to the extreme, to the positive extreme, where still the customer feels all that availability he can have and all the things he can get in that car in the most convenient way, in the most surprising way. Maybe later on with AI, you don't even know what's going to happen when you enter your car, but you feel good.
And it really comes down to that, as you said, consumers really once again driving. Now, pun intended there, what we're going to see in the next couple of years. So this is so interesting to me because, you gave the analogy of the smartphone and certain things that you will miss out on if you do not buy a certain phone with certain hardware. So when it comes to software, though, it's not as easy as some people might think because you still need that functionality with hardware and certain, pieces to be in place to then enable the software. So let's talk about the basic systems required in an SDV. How can automotive engineers balance the need to include more circuitry with the requirement to limit weight, especially in EVs, we're talking about that, in order to maximize efficiency and then all while meeting expectations around development cycles and, of course, production costs?
Yes. Yes, this is an interesting point, Michelle, what you are mentioning. And a circuit does not mean necessarily that it is a wire, right? What we know traditionally from the wiring harness is the circuitry of a car is basically in the wiring harness, and then you had some electronic in an electronic module, which is then running whatever system you have. And with the software-defined vehicle approach and with the high-performance computing centers, what you have, the circuitry is also moving. It is moving a little bit away from the wiring harness and more into those electronic modules. And that means that the harness complexity can be reduced, which is a good thing also for the wiring harness makers. Complexity, all these different variants, that's really an element to work with. And if this is done in a control module or if this is done in a headlamp, just imagine a headlamp with incorporated electronics or other modules which contain their own electronics and the zonal modules. So it's a little bit shifting. And what you see then between those centers of electronics, if you like, what you see then between is a data transfer. And the data transfer will get more and more. And this is a place how we could enable that with our data connectivity, which is transferring the data in a safe and reliable way. Then, of course, we are getting from one module to the other module, the data and also the energy. What is not changing, also to say that, is in the end all the sensors and actuators. This is maybe even getting more. So on the other side of the circuit, right? If you want to do autonomous driving, you need radar. You need those proximity sensors. You need cameras. All of that is growing, and also you need a lot more actuators to make things happen in a car. Also, that is getting away from mechanical or maybe electromechanical, and it's more into electronic things. So those actuators and things the car does is going to be expanded. That means on one side we are getting more, you're absolutely right, but on the other side the circuitry gets kind of like integrated into modules, and this in return is changing then also the our business, the connectivity between those modules.
The bottom line here, I mean, of course, we're talking business, so we want people and companies to make money on this. Everybody to win, right? The consumer gets what they want. The car companies and manufacturers, everybody's a winner here. So when it comes to manufacturing, what is happening today to make producing SDVs at scale both feasible and then profitable?
Yes, what you see is actually with the vertical integration, right? So the software-defined vehicle is also enabling a different way how a car is put together with the zonal architecture. And you see this modularization also inside of the car production. You heard about terms like gigapress, and then others they take it over. Also to go into a similar direction with huge body parts, an example, right? But then if you go with a huge body part, it also means that you need to pre-assemble something on that body part before you really put it together. And that means you have a different way of connectivity in it and automatically applied, and maybe also in a different way. It's not going anymore to be a round wire, but maybe a flexible circuit or a bus bar and this kind of thing. So these are the enablers for that software-defined vehicles. It's a give and take, right? One goes with the other, right? Software-defined vehicle goes with EV, and EV and software-defined vehicle goes with this vertical integration of how it's produced, which is why are people doing it? It is because you can reduce the production cost of a car significantly, and we see also that the contenders, the challengers, they are coming with those vehicles with lower cost, basically, and that makes them good for the new market. And the traditional ones are a little bit challenging, and they have to overcome, of course, this gap in cost, and they are going into a similar direction.
We're seeing such a quick rate of advancements here, but what still needs to change that is possible to achieve today?
That is a good question. And the definition of a good question is if you know or you don't know the answer. What I think we are in the midst of it, right? It's not. I don't see anything which is really holding it back. It is really a movement which is starting, and you have those challengers who are trying to do it in a different way. But technically, we have it, and I think, like with AI, it will even get another boost, right? It will get a boost because software-defined vehicles will even become more stronger and more better for the consumers, more connected, more easy, right? So we will see, with all of the things from the low-cost cars to the luxury cars, from the challengers to the traditional ones. I think we will see maybe some who will survive, some not. Everybody will try. So I appreciate this current situation really, because in my 30 years I'm in business now, I never saw a time with so many changes, right? Not only on SDV, there are also other topics, but that's really a lot what's going on, and for me it's a heaven of opportunities, and this is what it makes so great.
I'm curious to hear your thoughts on this next question, especially with the length of time that you've had in this career. What do you see as the barriers to SDV adoption? And then What can OEMs do to address these before bringing SDVs to market?
Yeah, I think the barriers is kind of like at the moment is the availability, right? Not every car maker, not OEM is having that yet. Everybody's working on it, and everybody is having the first, how can I say that, the first approaches, the first cells of doing so. But you see very clearly that there are companies doing it and companies a little bit, can I say, behind. It's not really behind. They're having a different approach, right? So we will see who will win that. The barrier in the barrier, what we will have is for sure the connectivity then to the infrastructure. And I'm coming from Germany, I'm living in Germany, and I cannot be proud of the connectivity in Germany because even compared to India, I think we are not as good connected with our cars to the infrastructure than we are in other countries, right? And China is maybe leading there. They have a lot of good infrastructure, at least in the bigger cities. They're using it also for other purposes. That's clear. But they can use it also for the connectivity, for making the software updates in the cars, for having a better navigation, for having vehicle-to-vehicle connectivity, and this infrastructure in many other countries, including Germany, I think is a little bit behind.
What is TE's role in helping OEMs develop SDVs?
Our role is on that physical layer, pretty much clear. We are not writing software, that's for sure. But with all the changes going on, what I said before, we can deliver those components in a customized way with our OEMs, but also in a standardized way with, for example, our data connectivity to make that happen. So I think we are prepared, and if I may say, our understanding what's going on in the market is, I think, crucial for having those components, right? With our advanced engineering projects and the technologies we are looking at. And so I'm glad to be with TE because here we have the ability to look at those market trends and to work on those technologies. We have the freedom to do that so that we can have the right products for our future.
Yeah, and there are a lot of factors in play, especially with the circuitry needed for the software that we're talking about. So, what is TE doing to help address the real world performance requirements of a fully customized SDV?
Mhm. Yeah, the answer I want to give there is for the data connectivity, right? And the data connectivity, you can imagine you have more and more cameras in your car, if you look at that, and the cameras need to be connected. Now, the cameras are pretty much connected then also to the high performance computers, and they are driving, or part of the drive is very much safety related, autonomous driving, even if it's a little thing like parking your car, and the camera helps you not only as a driver, but also in the system. With some OEMs, they're using the camera at least as part of the parking aid. And if you have that, you cannot afford that you bump into something, right? You don't want to hit the bumper of the next car. You don't want to have that. And that means that the system needs to be reliable. And part of the reliability is, for example, the latency, the so-called latency of how quick a signal can be transferred from the camera to the HPC, to those computing units, right? And if our products are more reliable, if our products have a high performance there, that they can deal with the amount of data and also deliver the amount of data in a good quality, then of course I can say we are an enabler for that part of software-defined vehicles.
I want to talk about the process. How is TE partnering with SDV OEMs? This is one more time, 3, 2, 1. I want to talk about the process. How is TE partnering with SDV OEMs? Specifically, when is an OEM typically pulling TE into its design cycle?
Yes, and also here you have a variety of approaches, as the OEMs have different approaches. There are some where we work very closely now, again, regarding the data connectivity. And this, for example, with simulation of this link, right? If you have a link from the camera to the computer unit, in the end, you can simulate these days how good the link is. You know the latency, you know the return signal, you know the performance of that, you know the performance of the wire too. So we can provide support to our customers of how this link looks like, right? Is it good for you? Is it not good for you? And then we have others where we are working very much on customized connectivity solutions to make things happen. For example, if you have a high performance computer, then you need to have connectors to that. And these connectors, they can be modularized so that you have, depending on the content, you have more or less modules on that. And, also together with the automated design, automated assembly, we can work on these requirements, and we are working on these requirements for connecting them with a robot. So this field we have, so it goes from standardized connectors until really customized solutions which are for specific.
Let's take a look at the future. In the realm of SDVs, what can we expect to see more of over the next 2 years?
Yes, so we have some which are going ahead and which are showing what's possible. And just to give you an example, I saw a nice video yesterday how a driver is putting on his screen, pointing on a free parking spot, and then the car is going into that parking spot automatically. Basically, he doesn't do anything. So we will see more and more. We will see that this gets adopted, and the most important thing is we will see of how the markets will react to that, right? And there are maybe markets which don't want that so much, and other markets where you see that way stronger. But the technology will advance, and we will see all of these opportunities. And I think we also will see that this autonomous driving is getting stronger. We have now the first cars which are going to level 3, right? They have it approved, and they can do that. And slowly but surely this will advance, and I think it will all get together to a new way of how we look at cars. And maybe in the future we will see also that a car is autonomously going to the EV fuel station, to get some electricity, and dropping the kids at school on the way to it, right? Let's see. We will see it, but what I love so much is that this opportunity is there, that this is moving, and it's a big move. It's not an incremental move, really. Something bigger is changing now in the industry.
Yeah, wouldn't that be nice? And picking up milk and bread on the way home would be an added bonus. So who knows what the future may hold. So how might the shift toward SDVs?
Sorry to interrupt you. I just wanted to say that for Germans, it's so important that the box of beer gets home. And just imagine you had a few and you want more, and you can send your car to get a box of beer. What a heaven!
Rudi, that is a great point, and one that I did not think of. But it's a little bit later where you are. It's closer to 5 o'clock, and we all know it's 5 o'clock somewhere. So I appreciate you pointing that out. No, it's definitely duly noted. So wrapping up here, we've kind of seen and talked about the ripple effect of technology in one part is really kind of seen in a lot of different other places. We've talked about phones and cars and just a variety of different things that can be affected. So how might the shift toward SDVs influence the design of other technologies such as city and highway infrastructure, as well as personal electronics?
Yes, it gets also there more systemic, right? We have seen it already now. A mobile phone is a system in itself, and it's very well working these days, and it's software defined in a way. And a car is not a mobile phone, for sure not, but in a similar way, we will see also this systemic approach. The next step is then how this all gets together, right? How do we make sure that all the mobile phones, all the smartphones are compatible to the cars, right? And all the cars are compatible to the infrastructure, and it doesn't stop when you go over the border to the next country. In Europe, we are not so big, right? So if we drive through from Germany to France, for example, to make sure that it stays connected, right? And you see that companies and governments are working on that to have that standard defined, and you see also in the industry that there is a way forward of they are different OEM by OEM, but in a way similar and compatible to each other, right? So we don't want to see we want to see competition in the future between the OEMs, what a software-defined vehicle is. But on the other side, we also want to see that there's some compatibility between the systems so that things can be exchanged, right?
Any final thoughts as we're wrapping up, and maybe resources that if people are loving this conversation, they want to learn more, where can they go?
They can go to TE, right? The entire movement means we need, for example, data scientists. It's one of the things. Also, our way of working will change with more software-defined and AI. So, data scientists is something that is needed in the future. In general, I would recommend that people look around with open eyes. The CES is coming up in January, early in Las Vegas. That is always a great place where you can get a glimpse of the future, what the companies are thinking about. So again, there's a lot of opportunity, a lot of competition, and that's why it's a so great time to be in and to be an engineer.
Wonderful conversation. I love how you talked about competition and going back to the beginning of the podcast, how, TE being a competitor and now you're here and really enlightening us on just amazing technology, software, and hardwired, and all coming together. And it's really exciting to see what the future holds. Rudi Ostermann is the Vice President and Chief Technology Officer for TE Connectivity's Global Automotive. Thank you so much, Rudi, for your time. Really appreciate it. And just a great conversation. So thank you for being here.
Thank you, Michelle. This was great and was really fun talking. Thank you.
And I want to thank all of you for tuning in and listening to our Connected World podcast brought to you by TE Connectivity. And of course, you can go to te.com for more information about TE. And you can read the article that we kind of opened up the show with that Rudi wrote about software-defined vehicles, allowing for these upgrades with ease, and who knows where the future will take us. So appreciate all of you tuning in. I'm your host, Michelle Dawn Mooney. Thanks again for joining us. We hope to connect with you on another podcast soon.